I'm very pleased today to have Adam Kilgariff to visit us here and give a tech talk. Adam is a leading expert in word sense. He wrote a PhD thesis many years ago on this topic and has been working with a lot of companies that combine like words best dictionaries, like Oxford University Press and so on. And so I'm very pleased to have Adam here because a lot of us sort of worry about word sense as well and meaning and so on. Even though mostly we do now is keyword search. All right, without further ado.
Thank you very much, and thanks very much for inviting me. And this is some English sweets to go round to accompany your high-quality food from in your canteen. How do we switch the?
Oh, sorry.
Thanks.
Do you know whose bag this is?
Oh, it's mine, sorry.
The Long Road from Text to Meaning, a rather grand title. First I'll talk about the research program that is trying to find our way from text towards meaning. And by way of examples, I'll use corpus lexicography, that's making dictionaries from corpora, and word sketching and thesauruses, and if there's time, a quick word on something we're calling collocationality. And a brief word about the data, and then coming back to the title. Do pass these on round, please. Let's start from something nice and straightforward and obvious. What's language? Well, there's one answer. And there's another answer. And the good thing about it is that we know what to do with them. That we know since Saussure, writing over 100 years ago, that we need both of those to have something that's recognizably language. But the issue rolls on. And it rolls on, we know both of those are necessary for language, but it remains as a methodological issue. How are we going to study language? Are we going to study the sorts of stuff that's in our heads, or are we going to study the stuff we find in texts around us? The first approach is explicitly supported by approaches, the competence approach as advocated by Chomsky, and that's in the rationalist tradition, and Chomsky makes his debts to Leibniz clear. Which is fine. Two things to say about it. Firstly, that this is a method for finding out about language that involves linguists saying, what do I know? Asking themselves, what do I know? Which is an unusual method for objective science. But quite apart from the theoretical objections, there's the practical problems that the approach to linguistics you get with that approach. People choose one topic that they're interested in and study that, but it's very hard to talk about all the different phenomena that happen in language because linguists don't happen to think of them. So that's the approach based on studying language in our heads. The other approach is to study text. Isn't it nice to think of language as something we can study in the same way that physicists study forces and chemists study chemicals? We'll be able to study language because we've got lots and lots of data in speech signals and in text. And that's the empiricist tradition in the line with the British philosophers, John Locke and David Hume. And a title I was tempted by for this talk was Rationalists and Empiricists in the Age of Google. But I decided that would be over-egging it. Something important to say about this approach is that it's when we're everyday language users, what's important about a sentence? Well, its meaning. we're mainly interested in what people say and what we're going to say in terms of the meaning of what we say. There's something about the corpus methodology, the empiricist methodology, of treating bits of language in the same way that chemists treat chemicals. There isn't any room for the meaning in that approach. We're going to throw away the individual meanings of sentences and just look at patterns. So it's always worth kind of remembering how odd a thing to do with language that is. And of course, it's with the advent of computers that this approach has sort of got renewed vigor and renewed strength. We're getting much better at finding patterns in large data sets from machine learning. We've got much larger data sets with corpora and the web. And we've also got, with the advent of computational linguistics, or the progress in computational linguistics over the last 20 or 30 years, we've got better and better tools which help us use the large data sets, like lemmatizers and part-of-speech taggers. Are terms like lemmatizers and part-of-speech taggers, everyone here sort of knows what I mean? And yes, well, if you've got an English word like inviting, then one thing you'd quite like to know is that it's a form of the verb invite, and that's what a lemmatizer does. So this sort of way of looking at language has had 15 years of, it's also new. My son is now a teenager, my oldest son, and at 14 he's, by my estimation, slightly older than the web, which, by my reckoning, 1994 was the year in which it started sort of hitting the newspapers and being talked about. So it's a teenager. I like the analogy between the web, which is sort of growing at an untrammeled and weird way and nobody knows quite how. The idea that it's now a teenager, this sort of seems to fit. So the model for this approach to language research looks a bit like this. That we can input lots and lots of data. We can find patterns in that data. We can then use those patterns to put into a lexicon. I mean, there's quite a lot of computational linguistic work in lexical acquisition from corpora. And that means that we had tools to start with, but we can improve the tools we've got for part-of-speech tagging and parsing and lemmatizing. And then we can always add in more data and then get more out of the data by improving the annotation on it and by extracting more and more patterns from it. And this is, to my mind, a way in which we can sort of make more and more progress at understanding the structures in language and the sort of stuff that language is. I'll illustrate it now with a few cases. Firstly, corpus lexicography, making dictionaries from corpora. This splendid fellow is James Murray, who was the editor of the Oxford English Dictionary between 1860 and 1927, when the first edition was published. He died a bit before that, in fact. Which goes to show that you really need a very long beard to write a dictionary. The stuff behind him, when I talk about corpora, that just means a collection of text, for any of you who aren't linguists and aren't used to that. So corpus lexicography is making dictionaries based on lots of evidence found in text. And that's his corpus behind him. It's the pre-computer age, so it's not on a computer. It's on a large set of index cards. There's a book called I think in the States it was called The Professor and the Madman, which was about, that was about him, yep. Or he was the professor, he wasn't the madman. And the process of developing that corpus, people all over the world read books, newspapers, whatever. They came across what they considered an interesting use of a word. They wrote the sentence containing the word on an index card, underlining the word that was the one of interest, sent it to Oxford, and then it got filed in that filing system alphabetically under the underlined word. And there are about 20 million of those, and there's lots of them in the basement at Oxford University Press, where I do quite a lot of work now. And I gave versions of this talk in two places recently where I was able to, one of them was Le Robert in Paris, and the other in the Netherlands. Two places where I was able to say, yes, and that's their corpus, like that's yours up there on the shelves, as it was in Le Robert. So that's corpus lexicography in the pre-computer age. It means when James Murray is going to write a dictionary entry, he usually got one of his children to go running along the corridors to find the right box file with the for the word, all organised alphabetically, of course, and then they'd bring that back, and that would be the evidence on which he'd base the definition for that word, which involves lots of running up and down stairs and running around to get the boxes. So around about 1980, the observation was made that the computer could do that very well. Of course, in 1980 it kind of wasn't, you didn't have computers on your desk in 1980. The computer was a large thing involving several rooms downstairs in the basement of the building, and sending a request to it involved sending it in paper and getting wadges of paper back. But what the computer could do was produce a keyword in context concordance, something that looked like that. That's a concordance for the English word party, or the English lemma party. And so what happened in the CoBuild project, which was the innovator in this work in the UK, was that the lexicographers were allocated work, were allocated these 30 words to write definitions for, and what they were given along with the allocation of the words was that much paper with all the keyword in context concordance lines on it. And what they then did was this, to mark it up, to do colour coding for the different meanings. If we look at that concordance, the first one is, which will be used to take a party of underprivileged children. Well, that's party meaning a group of people. We'll call that one the turquoise one. You are invited to a party, and after a couple of drinks, well, that's the social event party. We'll call that the green one. We believe politicians of all parties will listen to our views, so that's the red one. So we can go through this concordance, marking up different meanings by giving them different colours. And then when we come round to writing the definition, the dictionary definition for party, we first do the red bits, and then we first look at all the red evidence for the red meaning, and then all the green evidence for the green meaning, and so forth. And that's just the coding. And the important thing to say about that is use of concordances in that way has revolutionized lexicography. And it's kind of changed how the people writing dictionaries think about what they're doing. Previously, what was it? What was the source of the knowledge that you were going to distill and put in the dictionary entry? Well, it was in your head. But with corpus evidence, it's become more and more viable to say, well, what I'm going to distill is the concordance lines, is the sort of good evidence I get for what the word means. So that's been the biggest change in lexicography from the last century. Now I'll just mention a couple of the limitations of it. Well, as corpora get bigger, it's obviously nice to have more data and more evidence. And there's one or two chairs right over here if you want to squeeze through. It's not very good viewing lines, but we're on making dictionaries with corpus evidence. If there's 50 examples for a word, you can just read all of them and base your analysis on that. If there's 500 lines, well, it'll take quite a long time to read all of them, so maybe you don't want to. And if there's 5,000 lines, you're not going to be able to. So then we want to use the computer not only for delivering us the data, but also for summarizing it in some way. And the basic solution is simply this. You can make a list of the words occurring in the neighborhood of the head word with their frequencies. And then you can sort by salience in some way or other to find the words that occur most often or most interestingly and most often in the neighborhood. This is, and that's the sort of list you get. This was actually in the first paper proposing this approach in 1989 by Ken Church and Patrick Hanks, and looked at all the words to the right of the word save, of the English word save, in a corpus of, I think, 40 million words, between 1 and 5 words to the right, and added them and saw how often each word occurred there, and then applied the mutual information statistic to, and these were the top scoring items. If I sit down, I'll just give you a moment to take a look at that list. And if you're writing a dictionary entry for the word save, what's good about it and what's bad about it? Just take a moment to put yourself in the feet of a lexicographer. Any suggestions? Things
It's
people.
got a lot of uses.
Oh,
Well,
that's
a lot of the words that you see in collocation don't tell you anything about the meaning of save,
like
like thousands.
yeah. So thousands isn't very good. 1.2
Or your, or
Yeah.
annually, or.
Yeah.
Yeah, the face lights up. Oh, there's a meaning I haven't thought about.
Yeah. It's nice, that, doesn't it? Yeah. Any? So we like face. We don't like thousands. We don't like enormous.
Is this more normalized for like the marginal frequency of each of these words?
Yeah.
Although thousands cost dollars enormous, dollar sign up there all have monetary aspect to them, and so
Yeah. So it'd be nice to do some sort of clustering
yeah, so
in that way.
money
Yeah.
there.
Yeah.
You'll miss rare meanings.
Miss
You'll
Remy.
miss rare meanings if you only show you the top.
Oh yeah, well this is for purposes of fitting on a slide. Any other comments?
You sort of have no way to discern it from its opposite. Like waste might have the same
Yeah.
thing.
Yeah, that's true. There's often we might be able to come back to that. Yeah. So we've found some that we like. I mean, other ones that we like. We like face, and the other ones that we like are. Yeah, we might also see that life and lives could be put together, and that's this lemmatisation issue. It'd be nice to lemmatise. These ones weren't. And which other ones do we like other than which other ones look like good evidence?
Face.
And money, yeah. Lives and yeah. So all the ones that we like are basically the direct objects. And
Your is not very good.
no, yours definitely not very good. It's kind of quite surprising that your got in there at all. These ones, what's going on with these ones is enormous and estimated are the adjectives governing the direct object. So it's kind of interesting that they occur a lot, but they're not directly related to save. They're only related via the object. So we start wanting to think, well, if we added a bit of grammar in here, we could do something more useful. We'd like to get rid of some rubbish, and we'd like to do some lemmatising, and we'd like to add in some grammar so we can because we know that with verbs it's pretty obvious. It's pretty often the direct object that's the most interesting thing. Thanks very much. Thanks for the input. So that's what we've done with it. So the word sketch is like that previous slide, except it brings in the grammar, and bringing in the grammar tends to get rid of a lot of the noise as well. And so to make good word sketches, you need a large objects, modifiers, different grammatical relations. And then the statistics haven't changed much from the previous slide, but we can sort them to, but we can have a different list for each grammatical relation, so we can sort of say what different classes they fall in. The first version of word sketches went into making that beast, the Macmillan English Dictionary for Advanced Learners, and was Michael Rundle, the editor, and I talked about how we'd used word sketches at the lexicography conference in Copenhagen in 2002, and people sort of they got a good response, but various people came up afterwards and said to me, "Can I have them for my language, please?" And so far, I'd only really thought about doing them for English and hadn't given it any thought. So I said, no, it depends on having this large resource for English and other. And after 3 or 4 people had asked me that, and I'd given 3 or 4 of these very downbeat, negative responses, I thought, well, maybe we can do better. And the upshot of that was a product called the Sketch Engine, where the input is any corpus of any language, which we like to have lemmatized and part of speech tagged if possible, and then a specification of what all the interesting grammatical relations are for that language, for like objects and subjects and modifiers and heads. And then the system is integrated with a corpus query system, which means you can do concordances and sort them and find other patterns in a range of ways. Developer was Pavel Rychly from Brno. We've now got quite a few dictionary publishers using it, Oxford University Press and Collins and Chambers and Macmillan, and quite a few universities. My main reason for being in California is actually because FrameNet, the project at Berkeley, is using it. So I'm talking to them about how we can make the best use of it there. And that's the URL, but let's show it now. So that's a word sketch for the English verb engage based on the British National Corpus. So we had 4,000 examples, and by the time we've parsed to identify what the object is and then done some sorting, bearing in mind the marginal frequencies for the word, that's what it looks like. Any observations about the first 3 words on it in this first column? In relation to the verb engage.
Consultant's not one that would have occurred to me.
Right, there might, this is British data, so there might be British English British American differences.
They all correspond to different senses.
Yeah, exactly. So as we were saying with save face, one of the important reasons for using corpora in dictionary making is so that you don't miss any meanings, because it's pretty hard to think of them all without any external assistance. So it's kind of rather nice, this example, because it immediately says the very first 3 words it shows you are 3 completely different meanings of engage. Engage attention, that's a sort of mental meaning. Engage gears is the straightforward thing you do on cars if they're not automatic. And engage a consultant is employer consultant. I don't know if that usage exists in the States. So 3 completely different meanings that need separate treatment in the dictionary.
So we see engage almost exclusively being about
Fiancé.
Agreeing to get married. Is this a British versus English, versus American English distinction, or?
I've seen each of those used.
There's
I've seen each of
there's
those
man
used
and
there.
woman in the second column.
Okay.
In the second column, subject, let's see. It's always, I think that sense is always passive, which creates a complication. It means these are probably missed
Okay,
pars.
so engaged, so you're not stemming, and this would be engaged versus engaged.
Well, they should be treated in there. No, even those men engages are not. There's probably a part of speech tagging issue here that if we, I don't know. It takes a bit of. I mean, we can do a bit of debugging to see why nothing about that meaning they were engaged to be married is pretty common in Britain.
But it's not the verb in that sense.
Well, it's kind of it sort of is a verb. It's just a verb that has to be in the passive in that meaning. So it's surprising that it doesn't feature there. It might be that there aren't any obvious collocations in that meaning. And if we, because if we just,
God.
yeah, it's a pretty weak one. Yeah. If we look for specifically the word form engaged, I mean, a nice thing about having the data in a tool is you can easily enough. I should have no, I didn't delete this one. Yes, we haven't got many engaged to be married there. We could be a bit more systematic and take a sample, but yes, it seems like maybe it is a British American difference. Well, it's a pretty wide general purpose corpus, so if that's true, then it would be more about... It's quite surprising it hasn't come up there yet. But,
British national corpus?
this one is, yeah. We could look in other corpora. I've got American ones here too. We could also... we can also do an analysis...
Look for propose.
well, if we...
That has a lot of different meanings as well.
That's true.
Yeah, most words do when you start looking at them. So if we look at at a window between 2 and 5 words between 1 and 5 words to the right of engaged, we can do that too, and so we can we suspect that married might be there.
Fiancé.
Let's see what we get. So it'll look through all those examples and find the collocates to the left. Usually quicker than this, but as I was saying to Deccan earlier, I better not blame the internet connection when I'm at Google.
But it's going back across the pond, so there's probably more distance.
Yeah. There's not much discussion of engaged to be married in this corpus.
Four.
Oh yeah, so it is up there with 37 examples, not a dramatically high number. The word sketches are looking for pre-specified grammatical structures, and engaged to be married is it's a kind of double passive, isn't it? The first clause is passive and the second clause is passive too. So that's not a pattern I would habitually look for.
That's interesting. The seventh one, the sixth one is opposite of married, like engaged. Sorry.
We hope it's the opposite.
Work.
And this is the tool. Do play with it if you like. We've got lots of languages loaded in it now. So we've got sort of most of the biggest languages in the world: Chinese, English, French, German, Irish. No, not Irish. That's not one of the biggest. Italian, Japanese, and Portuguese and Spanish. And they're mostly web corpora that we've collected. So we've gathered other corpora as and when we can. And for most of those, I've worked with collaborators who are experts in those languages who've done things like know what part of speech taggers are best and set up the parsing. Okay. Back to the PowerPoint.
So regarding those first three words, like consult and the other two are corresponding to different meanings, is that also part of the algorithm to like find like the most common thing associated with it, then like find the second most common, given that the first one is not there?
We do. I'll sort of get onto that a bit because we do something pretty much like that. But that's that fits. Good question for leading on to the next part of the talk. Yeah.
Question. So is the idea that you sort of put in the syntactic knowledge, so engage is a word, and then you discover semantic knowledge, or do you also discover syntactic categories with that?
It's mainly using what we know about syntax to bootstrap both finding out about semantics, but also finding out more about syntax, because one would always hope to be able to improve the grammars that are used to parse the corpus with the output of the process. One of the sort of leading parsers for English that's around at the moment is one that uses detailed syntactic knowledge from the Longman dictionaries, the RAS parser, and so if the dictionaries if people use this sort of system to make the dictionaries better, that's going to improve the parsers, or the systems might be more tightly integrated than that. So I've shown you word sketches. I was also just going to show you we also thought, well, now we've got these word sketches, we could illustrate them, courtesy of Google Images, of course. So this is just add a bit of decoration.
Right, so how did you get these images? You search for the terms
stick the terms in Google image search and take the first one. Yes. I think we've got an online version of this where they change every so often, but we weren't too sure about the copyright status of that, so it's not on public display. I don't know. It's quite nice that culture gets you a sort of splendid image like the path straight.
Literature too.
Yeah. Yes, so where are we on the overview? Well, I've talked a bit about corpus lexicography and word sketching. Let's get on to thesauruses. A thesaurus is a resource that groups words according to similarity. Two types of thesaurus. Manual, like Roger, a picture of Roger, and WordNet is pretty much a manual thesaurus. And all the publishers' thesaurus, you know, Oxford has its thesaurus, and so does Collins, and so do all, and so does Merriam-Webster and all the other publishers. They're all made by people making judgments about which words belong together. But then there's also automatic thesauruses. Karen Spark-Jones, who died just last week, was instrumental in proposing the ideas back in the 1960s in her PhD thesis, and then Dick Anglin was central to my understanding of what was possible with automatic thesauruses. Also called distributional thesauruses, and the basic idea is two words are similar if they occur in the same contexts. And something to kind of puzzle about thesauruses is to what extent are these ones similar to those ones. Because thesauruses are extremely useful for language technology or natural language processing. Wherever you've got, the reason is really so simple. It's, I'll spell it out anyway. Is because the basic problem with language is you've got sparse data. There are so many words that you don't find most of them in most of the contexts. So when you come across a new sentence and want to understand it, you're pretty likely not to have found those words in those contexts, those words with those other words before. So call that the sparse data problem. I skipped over one there. Oh no. The basic question that you often want to ask is, do two words go together or two constructions go together? Does X go with Y? And you don't. And looking at existing data, you don't know because you've never seen them before. So let's say, well, we can't answer that question, so let's fall back on a variant of that question is, does X and its friends go with Y and its friends? And if they do, then that will provide indirect evidence that X goes with Y. And the thesaurus tells us who the friends are. So, and it's kind of a strategy that looks like, that sometimes goes by the name of backing off, or is similar to other strategies that go by the name of backing off. And here's an example. That sort of business of trying to find out what goes with what, and it being very helpful if you've got a decent backing off strategy, is kind of applicable in all sorts of areas of natural language processing, from speech understanding and spelling correction and in various parsing problems. One big parsing problem that I'll illustrate it with is conjunction scope. What do you reckon? Are the shoes old? Are the apples old? No, the apples aren't old. The shoes might be old, the apples aren't old. So there's a hypothesis there that, so this is a parsing problem because we want to know whether we put brackets around there before we add old, or whether we put brackets around here before we add apples. And the hypothesis is that you'll only get the scope that puts boots and shoes together before you, and has them both modified by old, when the words are similar in meaning to each other. And that's an example of, and this is some work, colleague Francis Chantry's thesis does quite a lot of work on this.
Sounds like a man with a wooden leg named Smith.
Yeah.
Where's the scope?
Yes, yeah. There are lots of scope problems in parsing, but this is one where we think the thesaurus is potentially going to be quite helpful and quite directly helpful, and first experiments on it by Francis were promising, if not, they didn't immediately solve all the problems. So that's one of, so that's kind of an example of this of an approach which can be applied to lots of problems, of using a thesaurus to find out which words go with which in order to find which patterns are most widely applicable. Of course, there's other sorts of thesauri you can use, and I was very excited when I discovered Google sets a couple of years ago, because that's also giving us thesaurus information about which things go with which, and would also be pretty applicable for these sorts of problems. So thinking again about these two types of thesaurus, automatic ones and manual ones, what things do they say are similar to each other? Well, in the case of automatic thesauruses, it's pretty straightforward. They're talking about words. Manual thesauruses, probably people who start innocently and naively putting words together into different categories of similar meanings, think they're putting together words, and then they think they're putting words in a hierarchy, and that's an appealing idea. But then they come across crane, and they see that crane either belongs with tractors and other machinery, or it belongs with geese and herons and other birds, and they think, oh no, it can't be words that I'm putting into this hierarchy, because some words have different meanings that belong in different places, or homonyms. So it can't be words, it must be word senses. There are problems with word senses. There are theoretical problems and practical problems. There's Plato and Aristotle trying to work out what meanings are 2,500 years ago. It started a long argument. It's still going on with that bunch of philosophers in the 16th century, and going on all over the world. It's going on in China as well, and it still hasn't reached any sort of conclusion. What philosophers have to say about word meanings is bewildering, to put it mildly. We hoped they were these simple objects that we might be able to manipulate and work with, and philosophers have just served to show us that they're very complicated, difficult, and not things we should trust at all. Most useful thing, to my mind, said about word meanings, or said about meaning by philosophers, was Wittgenstein's comment, "Don't ask for the meaning, ask for the use." That's the theoretical difficulties. There's a quick summary of the practical difficulties. So we want to use a thesaurus because it's a practical tool to help us with other tasks like words, like finding the correct parse structure or speech recognition. And lots of thesauruses say, well, yes, use me, I'm a helpful resource, but before you can use me, you have to do word sense disambiguation, because the things that I organize into structures are word senses, not words. Which would be okay, except there's a huge cost to doing word sense disambiguation before you can use those tools. Well, I've been involved in lots of work on evaluating word sense disambiguations, but I won't get distracted now, but I think it would be a fair comment to say that under optimal conditions, the best sort of approach is might get something approaching 80%, which isn't very good. It means something like, if you want to use this tool, first replace 1/5 of your input with junk, which isn't kind of very promising.
And humans, can you get 100%?
Well, yeah, kind of. It's not obvious what 100% means, because word sense is, owing to all those philosophical difficulties, are such awkward things that dictionaries typically give different sets of meanings for words and all those. So people don't get 100% if you view 100% as, if you measure it as into tag agreement. If you get
but most of the errors would be obvious to a human.
Yeah, mostly they're not errors that anyone wants to argue about very much. They're because there's an area of grey between the one meaning and the next. But what that little diatribe or aside is meant to, the conclusion from it is that we should really avoid word senses. because getting distracted into them means that we're introducing a whole set of other problems that are harder than the problem we wanted to solve in the first place. So we don't really want to say this word has 3 meanings or 3 senses, but in Wittgensteinian mode we want to say this word has 3 kinds of use, because if we've done that, then we've got something fairly well-founded and empirical that we can build on. How does that fit into the overall? So I'm a fan of automatic thesauruses, which manipulate words much more than manual ones, which manipulate meanings of words.
Can you say something on why you even want to say that it has 3 uses? I mean, that might be fuzzy as well. Can't you just get along with saying, oh, this use is similar to this one, but I don't really know whether it's 3 or 4.5 uses?
Quite likely, depending on the particular tasks. So, I mean, the sort of typical reason why people have wanted to use thesauruses in artificial intelligence a lot with with automatic reasoning, so to put meanings into hierarchies and then to be able to use ISA relations and that sort of approach in order to draw inferences. And so I kind of think that from artificial intelligence it's pretty desirable that that from an artificial intelligence point of view, then saying that don't talk about the meaning, talk about the use isn't very helpful, because they want things that they can that are in hierarchies that they can draw inferences over. So there's a set of pressures to be talking about word meanings rather than word uses, which I haven't really said much about here. That's the kind of counter argument. Or that's the thesis which I'm offering a position against in a way. And to come back to this overall picture, I hope things like the old boots and shoes example have given an indication of how the thesaurus is a particularly useful tool in this sort of looping around, because we can use it to find more patterns, and it's kind of lexical information that we can add in to improve our parsing and also other processes to get more structure out, so that we can sort of loop around. And because the other bigger part of the question is, well, we want to divide things, we want to sort of make progress in getting towards a richer and richer understanding of language, and we're going to have to do things about meaning in some way or other, or we'll kind of miss the point. I'll come back to that right at the end, actually, because that's it's there. This is just another example of this sort of looping process, the sort of thing we can find out when we've got a big corpus and in the right sort of database. Which words are most collocational? It's a question. Which words have a strongest tendency to occur in collocations? Which is maybe for this audience it won't be obvious why that might be an interesting question, but it's sort of a characteristic of some words do have very strong tendencies to occur with fixed patterns of words, and others are much more willing to go with whatever other words there are, much more promiscuous. They just go with whatever other words there are around. It's
Do you wreak anything but havoc?
Exactly, yeah. Well, we've got examples a bit like that. So this came up because for dictionary publishers, they'd like to warn their readers, or they'd like to tell their readers which words are particularly inclined, which words, beware of the word wreak, because you shouldn't use it with anything much except havoc, they want to be able to say. And that's useful information for language learners. So I was asked by Macmillan, can you help us work out where we should give information to our dictionary readers about words that have particularly strong collocational patterns? I thought about it a bit and realised that this collocation was an awful lot like entropy. And we could take every verb and look at the objects it had. We knew its frequency from the database, from the corpus. We knew its that's just a probabilistic version of that column, I think. And then this one's, and we could calculate its entropy in that column there, which was all very simple sums. And it meant we could work out which verbs had highest entropy for their direct object slot. and produce a graph like that, which maps frequency against entropy. And so we know, so it's actually the ones, and there's a bit of normalizing to do with the overall frequency, because there's a tendency for it to go up. And then we can say that the ones with the lowest score here are the ones where it's most worth considering telling the language users something about the fact they've got strong tendency to go just with a smallish number of words. Here are the words from the British National Corpus which had, I never remember whether it's highest or lowest entropy, highest collocationality. I'll avoid the issue like that. Most of them you can sort of quickly see what it is they tend to go with. Door was quite a nice one because there aren't actually that many things you do with doors. You open them and you close them and you shut them and you lock them, but they weren't, but there aren't many other verbs that door is object of. Place is most dominated by take place. Most of them are dominated by one or maybe two collocates. Any questions about anything you? Sorry? Yeah. Yeah. Pay tribute to. They're kind of mostly fairly obvious. Play tennis. Oh, we have got your example there.
What does spokesman call
Say, said, a misparse of. There's always parsing problems. So one thing that you get one thing that you get forever in journalistic texts is said the spokesman, and because it often occurs the wrong way around, it was impossible said the spokesman, and because we've got this, English usually has the subject in front of the verb, but where you've got quoted speech, it will often have it the wrong way around. So that's why it's firstly misparsed it, and then that's dominated by said or stated.
Are these all supposed to be nouns? So are they built out?
So all of these seem to have the same partner, like take. Take place or something. I mean, is that weird? Should it really be something else? Or?
Yeah, could you normalize these for like the frequency of that word that they?
Yeah, that would be a further sophistication that I've thought about but haven't done yet.
Like wreak havoc, havoc's rare, so is wreak.
Yeah. So this doesn't bear those frequencies in mind, and I agree it would be interesting to see how that would change things. The next bit I was going to say a tiny bit about in the talk was about the data. So all I've been proposing is, having lots of data is important. That's a simple summary of how data sizes have changed over the last 30 or 40 years. A nice straight line, providing you put a logarithmic scale up this side. Though maybe now we're going up steeper than that with the web. And that's great because the bigger the data set, the better the results you get, the more you can do. For you, and one of my main sort of research agendas is getting people to realise the potential and benefits of using the web for corpora. Until not so long ago, people would. It's quite, the web is so new that the British National Corpus doesn't have words like blogging because they didn't exist when it was built. And it's always worth remembering that. And people carry on using the British National Corpus, which was a very long and painful process of building. It involved lots of writing to publishers to get electronic texts, but that was done in the late 1980s and early 1990s, and the world is transformed as far as those things are concerned. I put these slides in mainly because I wrote a paper just recently called Googleology is Bad Science. So I thought I'd better explain what I meant by that in case people had read it and wanted to object. If we want to use the web as a corpus, then there's sort of two ways of doing it, either via Google or as I was, somebody I was at a meeting with the other day said, Google, didn't say Google, he said search engines with 2 O's in them. So we can use search engines with 2 O's in them or not. And it was very tempting to use the ones with 2 O's in because there are no setup costs. You can start querying today and you can immediately get some sort of evidence to test a theory. The methods of using them could be just using the hit counts, or using the snippets that are in the search results page, or you can find the page, which is like what some meta search engines do. There's one called Web Corp, which has been around a while, or you can find the pages and download them. There's been quite a lot of NLP research which uses Google or Yahoo and then for example, to gather lots of evidence. For example, these are two pieces of work that use the hit counts. There's one by Keller and Lapata which made 36 queries to estimate the frequency of fulfill obligation, and because they wanted to check various different forms of the noun-verb pair and various whether it, what the exact form was, and they had to try them all separately. And here's another quotation from some similar work. There's a small community of researchers doing this sort of work. There's a wonderful thing called the Corpora mailing list, which is the main discussion forum. The group has intense interest in query syntax and care greatly if there's one very marginal and minor change to the Google query syntax or the Yahoo's query syntax. So that was at the time they did the queries, that was a legitimate query with some wildcarding. It's not a very good way to do science, because you'll only give us 1,000 hits for query. You'll only allow us 1,000 queries for a day through the API, and I think that service is being terminated, or at least shows signs of not being trustworthy for the medium or long-term future. And the 10-word snippet around each search term, that's not enough. And you've got this ridiculous sort order. We want a random sample of all the instances of the word. You won't give it to us.
He's asked.
Untrustworthy hit counts. There's lots of. They're not trustworthy. I'm sure you know much more about that than me. Limited search syntax, no regular expressions, and of course they're linguistically done. You don't do lemmatizing and part-of-speech tagging and parsing. So there are all reasons for not doing linguistic research using Google as an interface to the web.
External interface to Google.
Yeah. Absolutely. Well, really, my agenda, the agenda of the paper I wrote is exactly not you. It's actually to say we want everyone else to have as good access to the web as you have. Which that's exactly the agenda.
One technique that I suggest to my linguistic friends when they play on some of these things, which the problem, of course, they care deeply, and most of my users sort of look
I know, yeah.
is add helicopter Cincinnati to the query.
Yeah,
Which,
you do some of that.
Then you get sampling. You get.
It's
tricky.
It's running. It's the wrong way around. Yeah, you can, and some of those methods have, and I've done that sort of thing myself. But you don't really know whether helicopter and Cincinnati are randomly sampled, and there's definitely not. And so, how many noise words, and how do you choose the noise words, and how do you compensate? Yeah. So this is kind of the moral of this story, that using Google looks very appealing because it's zero-cost entry. You just start Googling. But the reality is that if you want to do dependable, solid scientific research on it, it isn't really much of a shortcut, because you hit all the other issues. So things aren't replicable. And of course, commercial companies don't tell you the innards of how you're choosing which things to put where. So that's the justification for my comment there. So what I'm really involved in is the not answer here, which is, and I've been involved in things like we've set up a special interest, Association of Computational Linguistics is ACL, special interest group on the web as corpus, which wants to use open source methods. And some of you might be interested in our next workshop coming up in September. As I said, the corpora in the sketch engine, quite a lot of them are large web corpora. Oh, at this point, I have to say to Google, thank you very much on behalf of the academic community for Web1T, the trillion word, all the n-grams coming out of a trillion words of data. It's kind of wonderful. So how does all this fit together? Well, back to rationalists and empiricists. We've got one way of thinking about language is, well, there's two kinds of people who want to study language. And one set are the rationalists, and they're most interested in the meanings, and they want to work out things in the formal semantics tradition of how meanings of words go together to make meanings of sentences, and how an answer to a question happens to be, how you can present mostly how meanings of words want to go to meanings of sentences, and how meanings of sentences will combine to give new meanings. And that's that's the logic tradition, if you like, with And at the other end, we've got empiricists who are mainly interested in the raw data. And what tends to happen is that the empiricists starting down here and the rationalists going down there, and both of them think they're talking about the same thing as each other, but in fact there's this great big gap in between. And the sort of method with the spiral that I've been advocating here can sort of be represented a bit like that. Well, when it was raw text, we were just dealing with characters, with a string of characters. We weren't dealing with anything that we could talk about linguistically. Then once we've tokenized and lemmatized it, well, then we can start talking about words, which is better than talking about strings. So down here we're talking about strings. Here we're talking about words. Well, by the time we've part-of-speech tagged it, we're talking about, well, we've got a richer idea of what the word is. And then we can start talking about grammatical structure as well, once we've parsed it. As I said, I'm visiting FrameNet, and each of these stages makes it a bit more linguistic, a bit more like we're talking about meaning, which is in a way a response to your question earlier. We really want to meet up with those guys. We'd like to be able to talk about the different relation, the logical relations between related sentences. But it's an awful long way. And I'm keen to work with FrameNet because the approach there with frames as structures for conveying the meaning, for holding the meanings of words, is kind of the next step up on this agenda. So this is the long road from text to meaning. I think we're still an awful long way away. There are many other things to do between times, but join me on the journey. Thank you very much.